Hello everyone, welcome back. Today we are going to be finding the inverse of a cubic function. So quick reminder, how do we find the inverse in general? Well, we start by subbing y equals f of x. Then to actually find the inverse, we swap x and y and then solve for the new version of y by isolating it. Then we would, last but not least, sub back in the function notation in the event that the inverse is a function. So let's dive in. All right, so for this first one here, find the inverse of f of x equals x cubed plus 2. Step 1, I'm going to sub in y equals f of x, so y is equal to x cubed plus 2. Okay, then step 2 for the inverse, we are going to swap x and y. So we now have x is equal to y cubed plus 2. And now we just need to solve for y and isolate for it. So I'm going to subtract 2 from both sides to get y cubed is equal to x minus 2. Then I'm going to take the cube root of both sides to get that y is equal to the cube root of x minus 2. And this is indeed a function, right? There is no way that we can plug in some value for x and get two separate values for y as our output. Therefore, it is a function. So I'm going to switch back to function notation here and end up with the inverse is the cube root of x minus 2. Another way we could know that this is indeed the inverse is indeed a function itself is if we think about, well, what would the parent function look like, right? What would this graph look like essentially? If we picture what this graph would look like, we probably know that this graph looks like this. Right, so it's going to look, I mean, this is just a rough sketch, right? But it's going to look something like this. And then we have minus 2, which suggests to us that there would be a translation to the right by 2 in comparison to the parent function. And translating right by 2, or really any translation in general, is not something that can ever change a function to a non-function or vice versa. So since that isn't going to be the type of transformation that would actually change whether or not something's a function, we can say, well, therefore, the cube root of x minus 2 must be a function as well. Okay, let's move on to the second example here. For the second example, we have g of x is equal to 2x cubed minus 5, so same steps as before. Step 1, let's plug in y for g of x, so therefore y is equal to 2x cubed minus 5. Then we're going to swap x and y to find the inverse. We're going to get x is equal to 2y cubed minus 5. Then we're going to solve for the new y, so we're going to add 5 to both sides. So x plus 5 is equal to 2y cubed. Then I'll divide both sides by 2 to get that y cubed is equal to x plus 5 over 2. And last but not least, I'm going to cube root both sides. So y is equal to the cube root of x plus 5 over 2. And now again, this inverse must itself be a function as well. So I'm going to write it in the function notation for the inverse.